I'm Anil Kumar sharing with you concept of finding shortest distance from external point to a given line. We'll consider R2 in this particular case. The question here is find the shortest distance between the point P 2 minus 10 and the line R minus 2 minus 1 plus S minus 4 3 where S belongs to real numbers. So let's try to understand the concept here. Let us say the given line is something like this. So that's the line given to us. And let us consider that there is a point which is somewhere here. Now, the idea here is to find the shortest distance. Well, shortest distance will definitely be something which is perpendicular, right? So that is going to be the shortest distance. So we need to find a point Q right there, and this is the point P which is given to us. On this particular line, let's call this line L1 given by this equation. Now how do we find this point Q? That is one question. However, here we have to find the shortest distance. So what actually we can do is we could take any point on this line, right? Let's take any point on this line. Let's say that is another point on the line. We call this point as P1. A general point on this line. Now, the shortest distance PQ is what? From here, you can see that PQ is scalar projection of PP1, right? So the shortest distance becomes the scalar projection, right? So if I use this length here and I want to find what this is, then P to Q will be basically equal to, let me write down here, P to Q will be basically equal to PP1, right, times cos of theta. Correct? So, as you can see from here, the shortest distance PQ is a scalar projection of the distance between these 2 points. So if I take any general point, I can use the concepts of scalar projection and get the result. Perfect? So that is what we are going to do. So what we will do here is that we already know that point P is given to us as 20 minus 10. The line equation is given to us as R equals to minus 2 minus 1 and S is equals to minus 4, 3. Now, to find the scalar projection, we need to find the direction of PQ also. So what is the direction of PQ, which is normal to the line, right? So we understand that PQ is normal to the line. Correct? Now from the given equation, direction of line is given to us as minus 4, 3. So the normal will be what? We can flip this and change one of the sign. So that becomes the normal. Perfect. So in R2, it is very easy to find the normal. Once we get the normal, in that case, we can actually find the direction of PP1 and do dot product with this normal and get the projection. Correct? So let us find the direction for P to P1. What is that direction? So we know P is 20 minus 10. We also know a point here, minus 2 minus 1. So let's assume this point is minus 2 minus 1. Is it okay? So in that case, the direction from P to P1 is going to be what? It is going to be 20 minus minus 2, so that becomes 2, right? And minus 10 minus this, that becomes minus 9. which basically will be 22 minus 9. Correct? So the shortest distance PQ can now be written as equal to the dot product of this normal with the direction of PP1, right, with the normal divided by the magnitude of the normal, correct? So that is what scalar projection is. So let's calculate this value. So we know PP1 is 22 minus 9 dot, this is 3, 4, and magnitude will be square root of 3 square plus 4 square. Clear? And always this value is going to be the absolute value, correct? So we'll take positive value. So this is always a positive value, correct? Now let us calculate. What do we get? So 22 and 3 gives us 66 minus 36. That is a dot product in the numerator, which happens to be positive. Square root of this, is 5. So what we get here? So that is 0. 30 divided by 6 minus 3 is 30 divided by 5. And 30 divided by 5 is the value 6. So we get the answer here as 6. So the shortest distance is 6 units. So I hope the formula which we have used, rather derived, is absolutely clear. Now there is a standard formula also which you could use, provided you convert this into Cartesian equation, right? And in that case, you could use the formula that distance is equal to the absolute value of ax1 plus by1 plus c divided by the square root of a square plus b square. Right. You could use this formula also to find the shortest distance. So what I'd like you to do here is convert this to the scalar form in this form, use this point and find the answer, and then compare with the result given. Let me extend this and show you how we can actually find the distance using alternate method, right? So that would be interesting. So let us extend this to find distance using alternate method. So I'll take it on a new page. So again, the same question here. Find the shortest distance between the point P, 20 minus 10, and the given line R. R is minus 2 minus 1 plus S times minus 4, 3, where S belongs to real numbers. So from the given equation, we could actually write x value as minus 2 minus 4s, the y value as minus 1 plus 3s, correct? So we kind of get the parametric form from here. So if I rearrange the x value, see what the s could be here. So if I rearrange this, what do I get? I get x plus 2, right, equals to minus 4 s, and from here I could actually get s as equal to x plus 2 over minus 4. Did you see that? So these are kind of critical steps to convert a vector equation into a parametric equation. Do you see? And then a symmetric equation, correct? Now we'll do the similar steps with the y. So with this equation, we'll do y plus 1 equals to 3 times s, which gives us s as equal to y plus 1 over 3. Now both should be equal, correct? Both should be equal. So we get x plus 2 over minus 4 equals to y plus 1 equals to 3. Now we can cross multiply and then solve, correct? So we equated both these equations. They are both s, right? And from here, we'll just cross multiply. We get 3 times x plus 2 equals to minus 4 times y plus 1. Bringing them all together after opening the brackets, we get, let me rewrite this. Okay, now bring them together. So we get 3x plus 4y plus 6 plus 4 equals to 0. So that gives you the equation 3x plus 4y plus 10 equals to 0, correct? So that becomes your scalar Cartesian equation in R2, right? So we have the equation of our line as what? As 3x plus 4y plus 10 equals to 0. Now we need to find the shortest distance from external point P, which is 20 minus 10. Perfect. So what is this equal to? So that distance is basically equal to the absolute value of ax1 plus by1 plus c over square root of a square plus b square, right? Where a and b are normal, correct? So in our case, what is a and b? That is the normal 3 and 4, right? A and b are these values, the normal to the given line. Perfect. So from here, we can actually calculate the answer. So what we get here is, so a is 3 and x is 20. So we get 3 times 20 plus 4 times minus 10 plus 10, absolute value, divided by square root of 3 square plus 4 square. Correct? So this is equal to what? 60. And this is minus 40, and that is plus 10 over 9 plus 16 square root is 5. So that gives you 60 minus this is 20, 20 plus 10 is 30, 30 over 5, which is same as 6 units. Do you get the idea, right? So we get exactly the same answer, 6 units, and that becomes your alternate method. So I hope you understand and appreciate how these two methods are linked, and also the concept which we use, right? Finding dot product with its scalar projection and then finding the answer. I hope you find it interesting and useful. Now we'll try to use the same concept for R3 also and show you how, using both dot product and cross product, we could actually find the shortest distance in three-dimensional space. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.